Hello, my name is Chloe Larson. I am the team leader of Team 43414E. Just a bit of backstory on our team name. It came from the word can, which we converted each letter into the ASCII component, hence converting the ASCII value into hexadecimal, ending up with 43414E. I was the coder on the Carbon Calculator project.
Hello, my name is Caleb Ayers and I was in charge of the database as well as the GUI design for the Carbon Calculator project.
Hi, I'm Renee Kruger and I'm responsible for most of the research and documentation during this task.
So in this video we will be doing an introduction to the project, what we did, how we did it, why we did it, GUI design, we'll discuss the GUI design, the database and how it works and how it interacts with the application, and then next steps and future improvements on our project, as well as a conclusion just to wrap it all up.
Why we decided to create the Carbon Calculator project. The reason why we decided to create the Carbon Calculator project is because we wanted each Uber user to be able to see their carbon output for each month. We then decided, why don't we just show each user their carbon output per ride and then do a sum total? Which is what we did. We decided to do this because we wanted each user to have the ability to know what their impact on the environment is.
We did this by creating a feature which displays the amount of carbon emissions per ride in a table and gives the total amount of carbon emissions per month as well. The table shows information from TBL ride as well as TBL vehicle that were made in Access.
How? To do this, we first started off with creating an Access database. In the Access database, we had 4 different tables. We had TBL drivers, TBL vehicles, TBL ride, and TBL user. TBL vehicles stores the name, make, model year, and CO2 emission score per each unique vehicle. The reason we did this was so that there would be less data in TBL drivers by creating reusable records of vehicles that each driver wouldn't have to input the carbon emission scores and all the other relevant information of their vehicles every time a new driver was registered to the Uber application. The next table, TBL drivers, each one again had a unique identifier, vehicle ID, which was linked to TBL vehicles to the unique identifier there. Their name, surname, email, phone, and age. That was general user data that Uber might collect. Yes. The next table was TBL ride. TBL ride again had a unique identifier for each ride. It had the driver ID, the user being the user who took that ride, and then the driver ID being the driver who drove that ride. Then there would be the start location and the destination, which is important information for Uber to gather. The start time, the accept time, and the end time, again, general information, and then the distance. The distance was important when calculating the total emissions, as was the CO2 emissions score. The next thing we did was we created a connector class in Java using UCAN-Access, which is something we learned in school. We did this in order to connect the database to the Java program so that they could interact. The next part was we created graphic user interfaces, GUIs, or as we call them, GUIs, to make the function more accessible to potential users and to make it more in line with the Uber brand. So we tried to design the GUIs so that they resembled Uber's brand, whilst also creating our own design, so bringing in our own creativity there. And the next thing was the programming or the coding sections, where we created methods to, amongst other things, display the relevant information, calculate the total emissions, and most importantly, to calculate the total carbon emissions for each ride.
In this window, you'll be able to choose a user from our sample group. Once you've chosen a user, you'll be able to press the Let's Go button and see their carbon emissions for the month of September in 2023.
In this window, you can see all the normal options you'll find in the Uber application and our added-on option, the CO2 emissions. The user can choose this option to see their carbon emissions. If the user chooses any other icon, an error message will appear, directing them to the carbon emissions icon.
In this window, you can see ride information in a table. Table ride with 2 extra columns, one used for the calculation of the carbon emissions and the other one used for the output of the carbon emissions. You can also see at the bottom of the window there is a space where the sum total of carbon emissions is displayed by Emily in September 2023. From here, you have the option to go back and choose another user or exit the program completely.
The next steps of this project include areas where we are able to make improvements, along with the introduction of different variation and updates to our current carbon calculator feature. Areas in our code where we could improve. We should add a user login page to our project. This page would enable users to log in, and we would then check them against our database to determine if they already have a profile. We did not do this due to time constraints. Some future improvements we have in mind include a feature which allows users to select specific car based on the carbon emission predictions. This is how it currently looks like when someone orders a ride from Uber. We would like to change it into this. As our user orders a ride, they can view estimates of carbon emissions for each available car, giving them the choice to opt for a more eco-friendly vehicle. For example, UberX might display a lower estimated carbon emissions, empowering the user to make a more eco-friendly, conscious decision. In the next future aspect, users would receive notifications suggesting that they delay their ride slightly to reduce their carbon footprint, especially during peak traffic congestion hours. The final aspect of this feature allows users the opportunity to share their ride with strangers heading in the same direction. By sharing a ride, users not only split the fare, but also the carbon emissions, collectively decreasing the overall carbon footprint generated by all the passengers who chose to share the ride.
So to conclude, why we did this so Uber users could see their direct and individual carbon footprint whilst using the Uber app. What did we do? We created an carbon emissions report functionality for the Uber app for users to see their direct carbon emissions report monthly and per ride. How we did this is we created an Access database, which we then connected to a Java program, and created a graphic user interface, which we then integrated to calculate each user's individual carbon report and then display it. We understand that this feature has a lot of room for future improvements and growth, such as an alternate login page, the ability to choose a ride, share a ride, or delay a ride using the data collected carbon emissions. Thank you so much. And just a quick thank you to Dr. Fatima Rajamani, our IT teacher. Without her, none of this would have been possible. We wouldn't have been nearly as knowledgeable as we are, as well as Samuel Abrahams, who helped us with the GUI design. He's a classmate of ours and he has a very amazing talent for graphic design. So thank you a lot to both of them.